Hello, happy Friday. This is actually the second live stream today, but this is the official. I don't know the answer to that question. Sorry, my computer is beeping at me. Okay, welcome. Everything is going wrong. First of all, hello, how are you? I'm out of sorts, even more than I usually am. I had a wonderful trip this week. I was in Zurich, Switzerland, which I'd been to before, but not in many years. And I had a wonderful time. And then there was this snowstorm in New York. Now, I keep thinking every week is going to be the week that I finally take away the snowy, is this the snowy one? Yeah. The snowy, wintry themed coding train background wallpaper. No, there was like all this snow and my flight was canceled, then I got another flight, and then that was canceled, and then I had to change this, and then I ended up actually flying through a place I had never been before, Iceland. I was in Reykjavik for approximately 1 hour and 10 minutes. I did get a little picture out the window of the airport, and now I feel like I've really got to go back to Iceland. Do I have any viewers from Iceland? I was listening to everybody on the plane talk about their vacations, and I was only there in the airport. So, oops, I'm in the wrong screen here. Hopefully everything is working fine. So, I'm operating at 50%, and since my brain capacity is at a normal day is really just like 50%, I'm really operating at 25%. But I'm gonna make do. I'm gonna put my energy into this, and I'm gonna make do. So what I thought I would do, I got back late last night, and I just didn't have the time to kind of get myself settled into the mode where I felt like I wanted to continue the trajectory of neuroevolution. That sounded weird. So I think what I would like to do is tackle a topic. I am sure, there's a new print. There's a new printer on my network. What could it be? What network am I on? Why is there a new printer? Oh, that seems suspicious to me. Let's turn off the Wi-Fi here. Okay, because I really just want to be on the Ethernet network. So I'm going to this repository, Rainbow Topics, which I think I should probably change to like train stations or something. I've still historically named a lot of these with the word rainbow. And I want to look up QuadTree. Don't worry, I will explain what a QuadTree is. And it is not an octtree or a tri-tree. I don't know what other kinds of trees there are. Look at this. Coding challenge, QuadTree, spatial distribution, coding challenge, QuadTree, just QuadTree collision detection, octtree. Oh. Okay, my capacity is definitely not 8 times today. All right, so let's look at this. So I'm just curious. Let me just click on these 3. Let's do some GitHub maintenance here at the beginning of the coding train. For optimizing 3D. Right, octtree is what you would use for 3D, right? Because QuadTree for 2D. Okay, so going to attempt this today. Closing in lieu of, so what was the first suggestion? I like to usually keep the oldest one, which was August 5th, 2016. So August, this is a nice one, August 5th, so this one, okay. All right, let's thumbs up this. Oops, no, I already thumbs up it. This is 144. Going to attempt this today, closing in lieu, is that the right thing to say? In lieu of 144. Thank you. Smiley. All right, that's how I'm feeling. Woohoo! Let's copy paste this. And I'm going to write the same exact message here. And there we go. So now we've got QuadTree collision detection. We're going to go up to QuadTree Wikipedia. Oh boy, this is not going to go well. Woo, I like this image though. So this is what we're going to make. Ooh, this is a really nice image. Lovely image. All right. Hexadecatrees, perhaps. I'm just looking at the chat for a second. I don't think I've ever been to Sweden. There are so many places that I have never been to that I would like to go. Someday, the Coding Train World Tour will happen. But right now, I don't really have the budget for that. But we'll see. We'll see if we can work that out. Okay, so Quadtree. No, okay, before I get to Quadtrees, let's do some housekeeping. First, I'm going to go to the Twitter account of Cat Small. Kat did a guest tutorial about the Phaser.js library this afternoon. It is linked from her Twitter at @catsmall. This YouTube link right here. It is an unlisted video because I haven't cleaned it up and figured out how to done that sort of like last pass over it. But this link will work. So if I click on this here, this video should start. It has me in it, but eventually it has Kat in it. Oh, look! The Coding Train is live now. Oh, let's go check that out. Oh, live now. Oh! All right, so... It has me in it, but eventually it has Kat in it. Oh, look! I always love this recursive thing that happens, where now it's going to infinitely do this over and over again. All right, I have to stop that. So I encourage you to check this out. This was this was wonderful for a couple reasons. Number one is Kat is amazing. She is a super awesome presenter. She gives a lot of talks at conferences. She makes a lot of games. So you should go and learn about her work if you don't know about her work. And she was incredibly well prepared, which is something you know that I am not good at doing for my videos. So, and there's a thoughtful example there. There's links to it. There's links to CodePen. So I really encourage you to check that out. Oh, maybe it's not unlisted. Great. No reason for it to be unlisted. It's listed. Wonderful. So I wanted to mention that. So I wanted to mention that. Number two, housekeeping-wise, I am here today. I will be back again next Friday. I have some exciting plans. I will be continuing my series on neuroevolution, and eventually we'll get this combination of genetic algorithms and neural networks all embedded inside this little Flappy Bird, which will learn how to play this game, and wonderful things will happen, I hope. Sentences are not getting put together. I think I need to work on something that's like just like a coding problem, and I think things will start to click into my brain. It's also warm in here again. All right, so that's my housekeeping stuff. I don't have any housekeeping stuff. Let's just get started. I don't have a lot of time today. I have to go to sleep. Rodrigo says, how do I tell him that he forgot to close a suggestion on GitHub? Well, today is your lucky day. I happened to just peek at the chat that very moment. So let's take a look. And let's look for Quadtree again. And I can't spell Quadtree. And this is the one that, thank you to Me I Am So Me for taking care of that for me. Oh, the internet is amazing. Would love to come back to Finland. Ooh, I have not been to Finland either. I have been to Norway. Let me tell you about a place that I have been to in Norway that I absolutely love. It is an island called Runde, and I apologize if I'm not pronouncing that correctly. Runde, Norway. It is near the city of Alsund. Oh, let's look at this. It is a little island. You get to it by driving over a bridge. There it is. I believe it's known as Bird Island. I don't know if Runde actually translates directly to Bird Island, but I have so many wonderful pictures. And there's Runde Bird. There's like a science center there. I don't know what to call it. Bird something or other. Environmental Center, yes. The Runde Environmental Center. This is a nice panorama picture. Anyway, amazing hiking. I hiked. I don't know why I'm telling the story right now. There's a funny story. Not so funny, not so funny. We did the first time I was there was with my family. We did a nice long hike. Took about a half an hour up to this top of this hill and got this beautiful view of all these birds. Went back down, asked somebody, oh, how's the hike to the lighthouse? It's a little bit longer than that, a little bit harder, but you'll be fine. The hike to the lighthouse was like hours and hours and hours and very steep. I was with small children at the time. And then we got there, got there after hours and hours of hiking. And the lighthouse, the only way to get there is by hiking. And the only way to get back is by hiking. But I did ask the proprietor of the lighthouse, is there a boat by chance that could take us back? No, she laughed at me in a very friendly, wonderful, warm, and welcoming way. I highly recommend this wonderful little spot. I hope to go back there again. I'm kind of into into bird ornithology. Is that the right term? Anyway, I'm way off topic now. Can I get like a satellite view of this? Oh yeah. Yeah, here it is. Oh yeah, look at this. So this kind of is where the road is. There's a campground. Where's the lighthouse that we hiked to? Is that it here? I think this is the lighthouse here. Does that look like a lighthouse to you? No, there's like roads there. So wherever we went to the lighthouse, there were no roads. I think I need some 3D going on here. Okay. It looks like the lighthouse was like out over here or something. Okay, you're not interested in this. I'll do this on my own time. I heard a camera go off. All right, so is he making this in anything in this live stream? I don't know. I'm procrastinating. Remember this afternoon when there was like a thoughtful, prepared presenter? Let's come over here. Let me talk a little bit about Quadtrees, and while I erase the whiteboard. So I've actually been wanting to do this for a very long time, and I'm embarrassed to admit, well, no one should ever be embarrassed about anything about coding and learning to code, that I actually have never implemented a QuadTree before. I kind of know what it is, and I did actually write some code for one on the airplane. So when I say I haven't never implemented one, I hadn't until yesterday when I was on the airplane. And I thought, oh, let me give this a try because this is something I can do without internet. There's something very loud going on in the hallway. You would think that noise was me watching the whiteboard, but it was not. But one of the things, and I don't want to get too far into this because I want to include this in the sort of edited portion of the video. But one of the things that's a common thread in many of my tutorials and videos is a particle system. That could be a system of like flocking birds. It could just be particles making fireworks or particles making a waterfall. It could be particles that all have magnetic attraction to each other. It could be particles that are all bouncing off each other. There's so many kinds of collections of things, collections of particles. And if I ever want to have every particle check every other particle's location, this is something that is an expensive algorithm to do. And in fact, it's an exponential algorithm because if I have 10 elements and each one needs to check its location relative to the other 10, that's 100 checks. If I have 100, that's 10,000 checks. If I have 1,000, that's 1 million checks. So while the amount of particles is going up by 10, the amount of checks is going up by 10 squared. I think that's right. So anyway, I'm getting kind of into too far into the explanation. So I'm gonna double back and start this over in a second. But a quad tree is a solution. I just want to mention that I do have the thing that I always had done before, which is not as sophisticated. And if I go to Nature of Code Examples. Why did I pick this algorithm for today? And if I go to Agents, and I think if I go into, bin lattice spatial subdivision, do I have these examples on this computer? I have the P5JS ones, but I don't think I have. Anyway, I have this example, which you could take a look at, which implements a particular algorithm that divides the canvas, the window, the two-dimensional area into a grid, and each element registers where it is on the grid. And so what I can do is, instead of having every element check every other element, each element can check the other elements that are registered in the same area that it's registered in. And this reduces the number of checks significantly. But it has a big problem, which is that it treats the entire space equally. So it doesn't matter what the actual distribution of the particles are. Each cell of that grid is the same size. What a quad tree does is it's a way of creating this grid, of sectioning off parts of the space, but providing more and more detail where there are more and more particles to allow for the retrieval of particles within a certain area in a more detailed and efficient way. So this is what I'm going to attempt to implement. So what do I need to implement this? I need a brain that is working better than mine currently is. I need some P5 stuff. I also am of a mind to turn, I would like to, I really want to make a tutorial about building a processing library. And I was thinking, actually, I'm going to do this in JavaScript today because I think it's actually, this is but easier to implement in JavaScript just because JavaScript is so flexible in terms of what you can do with arrays. But I was thinking that maybe what I might do in the future is make a JavaScript, and there are JavaScript libraries for Quadtrees, but make a Quadtree library that you could basically just pass it a whole bunch of objects. And as long as those objects all had an XY point associated with them, you could then also pass it like, oh, here's an area, give me the things that are in that area. So I'm thinking about turning this into a library at some point. I am going to just do this, get rid of draw. I'm going to do this ridiculous thing that I do because I can't help myself. I don't think I need DOM or sound. And then I want to go to the browser and localhost. I guess I can take out these links right now from PyDay. And, oh, I should show some of, one thing I could possibly do is just really quickly go to twitter.com hashtag, oh my God, PyTrain. These are some things, look at these, there's some things people made for, these are animated the first few digits of pi using processing. This is a nice one. It got 3 more digits and modified them by shape. Another one. Here's another PyTrain visualization. So these are some, this is from something else, PyTrain. Still, so anyway, I just wanted to show that some people were making things. Is nobody really saying anything in the Slack group? I guess that's the case. All right. So, Quadtree, let me close this. I've got the Wikipedia page up. So the Wikipedia page actually has pseudocode for this algorithm, and it's here. It has like an object to store an XY, an object to store a rectangular area, and then the sort of Quadtree class, Quadtree object that has a capacity. So I could maybe copy paste and sort of write it from this pseudocode. I think though I'm going to kind of program it from without looking at the pseudocode, and I'll reference it if I need to. All right. Okay, just give me a second here. All right. I'm ready now, officially ready. Brain power, activate. little lightheaded. That was a very long whistle coding train. Let's not have that. Let's start over here. Is my mic on? Yes, it is. Okay. Really? It's just like something is weird is going on here. No, I guess just nobody's posting anything. Okay. Hello. Hello. Welcome to a coding challenge. In this coding challenge, I am going to attempt to make a quad tree. Now, you might be asking yourself, and it's a perfectly appropriate question, what is a quad tree? What is a quad tree and why do I care? Well, let me talk about that over here. So something that you might have noticed in many of my videos and various things that I've made is, ooh, look at this beautiful marker. Wow, really made a nice rectangle there. That I create a lot of systems that have a lot of what you might call particles in them, or little agents that flock around the screen or that bounce around or bump into each other, have magnetic forces. And one of the elements of doing that, one of the elements of these kinds of scenarios is that for every particle, for every dot, for everything that's in my two-dimensional space, I have to check its location relative to all the other ones. So this one I need to check relative to all the other ones. This one I need to check relative to all the other ones. And that is a lot of checks. For example, if there are 10, if I have 10 particles and I want to know the distance between each particle and every other particle, I need to perform 10 times 10 checks, which is 100. Now, of course, there are like little optimizations there that I can reduce the number a little bit, but at its core, this is the idea. So this is what's known as an n squared algorithm, because I have n elements and I need to do something n squared amount of times, which means if there were 100, then suddenly I need to do 10,000 checks. And if there were 1,000, I suddenly need to do 1 million checks. If it was a pinky, maybe? I'm not so sure. So you'll notice that these are going up by a factor of 10, but these are going up by a factor of, well, not 10, 10 squared and more, right? Because this is 100 times this, and this is 1,000 times this, so it's exponential. So this idea here that can we do better? Well, I have an idea for you, because I'm really thinking about this. My idea is, well, okay, what if, I got this. What if instead of, like, for this particular particle right here, instead of checking all the particles, why don't I just check the ones that are near it? Like within a slight range around where it is. Oh, okay, but how do I know which are the ones that are near it? Okay, let me check all the particles and see which ones are near it. But then I am checking all the particles again. Is there a way that I somehow could create these sort of regions of particles and then ask, give me just the particles within that range without having to then suddenly go through all the particles? And in fact, there is such a way. And that one way, there are many ways, is known as a quad tree. Now, the reason why it's called a quad tree is that the idea is to take a space and section it into four sections, quad. And each of those sections could potentially be sectioned into 4. And those could be into 4. And the reason why it's a tree is that the sections, I don't know, there might be about the cells, the tiles, actually include references to their subsections. And so it's like a tree, and there's going to be a recursive algorithm here. So we're going to start with this idea of a rectangle, and that rectangle will store a reference to 4 rectangles, and each of those 4 rectangles will store a reference to 4 rectangles. But here's the thing. They only are going to need to store a reference to these children rectangles if there are a lot of particles in their area. Otherwise, they can just keep track of their particular particles. So the idea is that I can take all of these particles, register them inside of this quad tree, and then the quad tree is something I can query to say, hey, think about this part of the window, this part of the canvas. Just give me everything that's there. And it's going to reduce the number of checks by a lot. I'm pretty sure, I should go look this up. I think this is most likely turning this into n log n. So instead of n squared, and this has to do with something called big O notation, which is a way of notating how expensive or how long an algorithm takes based on the number of elements that are part of that algorithm. So an n algorithm is wonderful because if there's only I just want to draw 10 things, that's an n algorithm. Check everything against everything else, that's n squared, and log n is going to reduce that number quite a bit. Let's go to the Wikipedia page for Quadtree and see if I'm right about that. Just pause for a second. I'm going to find, yeah, it's just log n? Point Quadtree. Constant time. Is it just log n? Not n log n? Oh, but it is n log n because a lookup is log n, but I'm going to do it n times, right? Can somebody confirm this for me before I moved on? Yeah, it's 10 times 9, not 10 times 10. That's what I mean. Like, we don't have to check the, but that's sort of not relevant. I mean, because, it is relevant. Sorry, it's a good point, but I didn't mean to, it's a very valid question and a good point. I just mean that, does this idea change very much if this is 90 and this is like 100 times, like 99,000, whatever it is. Okay. Yes, O n log n. Okay. So it's under point Quadtree, which is what we're going to do. Okay, let me come back here. Okay. Okay, so this is the Wikipedia page for Quadtree. This reminded me that I didn't mention that there are also other kinds of trees, like an octree, which you might use for 3 dimensions. And you could just say K-tree for any generic amount of subsectioning. But I'm going to really just implement the sort of standard Quadtree, also known, I believe, as a point Quadtree. And if you look here, it says operating in O log n time. So you might have thought that I got this wrong, because I said n log n. But I think I'm actually correct here, because the idea here is that to look up a bunch of particles for a given area, that can happen in log n times. But in this, where I want to check every particle against every other particle, I need to do the log n thing n times. So this, let's just look at the 1,000. Instead of 1 million, this would be equals 1,000 times log of 1,000, which is just 3,000 checks. This is a massive improvement. Woohoo! All right. Pause, 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 pause. A question has been asked in the chat. Wouldn't you have to restructure the Quadtree every time an object moves? And in fact, the answer to that question is absolutely 100% yes. This Quadtree is something that, for collision detection, that you have to build each frame of animation. And there is a lot of time that it takes to build the Quadtree. But it's totally worth it. Because if I can get this 1 million number down to 3,000, and just think about it, if I had 10,000 elements, how much I'm going to be able to reduce it, it's worth building the Quadtree. Okay, so what do we need to make this Quadtree? I'm going to make an example using P5, but I'm going to, and let me make another JavaScript file. I'm going to call it quadtree.js. I'm going to build the Quadtree code. Hold on, let me just get rid of this message. Sorry, Matthew, you can edit this part out. Quick click, update will be installed. Oh, fine, I'm just going to relaunch Atom. Thank you very much. Shoot, I forgot what I was saying. I'm going to do this again. I'm going to add a new file called QuadTree. Fail. Total failure. Try this again. I'm going to add a new file. I'm going to call it QuadTree.js. So this is where, even though I'm going to use P5 for this example, I'm going to write the QuadTree algorithm in JavaScript with no P5 dependencies. That way it can be applied to lots of different scenarios with other frameworks. Okay, so what do I need to build a QuadTree? Well, I need a few kind of core elements here. For example, I want to have a point class. And a point class is just going to be something that stores an x and a y together. And again, I'm going to be doing a QuadTree in 2 dimensions. I also want to have a rectangle class. And a rectangle class is going to be, I could have a point. You know what? I'm going to do something a little goofy. I'm going to give it an x and a y and a width and a height. So I need these ideas. I need to be able to make, and I could use a P5 vector for the point class, but again, I want to build this without any P5 dependencies. So I need these data structures because the way I'm going to make this QuadTree work is by feeding it points. I'm going to say insert points into the QuadTree, and the QuadTree is going to have, as part of itself, references to all of these rectangular areas. Okay, so now let's make a QuadTree class. So what do I need to make a QuadTree? Now here's the thing, think about this. A QuadTree, oh boy, you might go back and look at my binary tree video tutorial or some of my other videos that have to do with recursion, because what you might think is, oh, I'm going to have an array, and the array is going to store a list of all of these sections or tiles or rectangles, but I'm not. The QuadTree is actually a reference just to the large kind of parent, the sort of root level rectangle, that area, and it's going to have a reference to the 4 things, the 4 subsections, and those will have reference to the 4 subsections. So that's a tree. So actually, a QuadTree only has the only bit of data that I really need, and we'll call it a boundary. This dot boundary, and that boundary is going to be a rectangle. So for example, in sketch.js, I might say, let Qt be a new QuadTree, and I might say, let boundary be a new rectangle. And you know what? I think it's going to make life easier if the rectangle is something that we think of as centered, registered around its center point, and those width and height values are actually just the distance from the center to the edge. So not the full length of each side, but the half length. So I'm going to say the boundary is at 200, 200, well, with a width of 200, 200. That's kind of awkward, but fine, because it's 400, 400. Okay? So I'm going to create this QuadTree with a boundary, console.log Qt. So this is like a beginning point, a starting point. So let's take a look. Rectangle is not defined because I forgot to reference my new JavaScript file here in my HTML file. QuadTree, as a boundary of a rectangle, it has these properties. So far no errors, we're moving along. Now what do I need to do next? The thing that I want to do with any QuadTree is I want to say something like, let me make a little loop, and I'm going to just do it one time. And I'm going to say a point, I'm going to make a random point and a random area in the canvas. And I want to say QuadTree insert that point. The idea is that what I want to do is I want to take all the points that are within this space, and these points might represent particles, any type of moving agent or entity, but right now I'm just going to build the static QuadTree with static points. I want to insert them into the QuadTree. So an important aspect of the QuadTree is a property known as capacity. So how big is the QuadTree? When do I choose that I need to subdivide? For example, if I start putting particles in this section here, oh, maybe once there's 10 particles in that section, it's gotten too big, I need to subdivide it. So a typical thing might actually be to just have that actually be 1. As soon as there's more than one particle in that area, subdivide. But let's pick the number 4 as kind of an arbitrary capacity. And it might make sense to create a quad tree with a given capacity. So when you create it, so I'm going to say capacity equals n. So now in Sketch, I'm going to do quad tree boundary comma 4. So this is a quad tree with each section, each rectangle having a capacity of 4. Time out for a second. Oh yeah, so I have a mistake there. I think I want to make the font a little bigger. The font seems a little small. I don't know why, if I shrunk it since the last time I was coding. And I can move this over here. And then this needs to be height. Thank you. Thank you, Henno, who points out this needs to be height. Just pausing for a second here. OK, there is a little error here. This should say height. It doesn't really matter here because it's a square, but just for the sake of argument. And timeout, my auto format on save is turned off. Let me go back. Let me do that too. OK, it's back. Thank you. I know I'm muted. That's so weird. Why did it mute? All right, everything's OK. That was really weird. OK, I'm going to wait now until you guys catch up to me because I'm not getting the notifications on my watch. Oh, they're on. I don't know. That's weird. OK, the mic is back on. Sorry about that, everybody. Let's try this again. OK, it was just pointed out to me that I did have a mistake here. This should be height. It is a square, so width and height are equal. But if I want to set myself up for success in the future, let's try to correct that and put height there. OK, so now I need to go here, and what do I need to do? I need to write this insert function. Insert, and what do I want to insert? A point. And so what I need to do here, oh, wait a second. I'm missing something super important. What is the quad tree? What does each tile need to have associated with it? Well, we know it needs its boundary. We now know it needs its capacity, but also needs to keep track of a bunch of points that are part of it. So what I can do here is say, as long as the length of the points array is less than the capacity, then I can just say this dot points push what? The point. Now I'm going to just time out again for a second. I'm sorry, but thank you everyone in the Slack group posted these animated, colorful, rainbow kitty cats, and I can't look at I can't look at that anymore. It's in the corner of my eye. It's making me really crazy. So you'll understand in a minute why I am typing these messages. OK, great. All right, OK, we're good. I'm just thinking about this for a second. Okay. So I've inserted the point. Now, what if the capacity is full? Well, if the capacity is full, then what I need to do is subdivide. So I'm going to make this into a separate function. I think if you look at the Wikipedia page, the algorithm that's outlined there kind of does the same thing. So I want to make a function called subdivide. And what that function does is it takes any rectangle object, remember that has an x, y, and a width and a height, and subdivides it into 4 sections over there. And so all I need to do is compute these 4 points and these 4 width and heights. And I'm going to store those in variables. And a way that you could do this, right? I think I've done this as like top left, top right, bottom left. Another thing that I've seen done is north. So northeast is this, northwest, southwest, southeast. And so that's the sort of convenient way I can refer to these tiles, these subsections, as northwest, northeast, southwest, southeast. So just to be kind of concise about the words I'm going to use, I probably should type these all the way out actually. So let's do this. This dot northwest equals a new quad tree. So I need to make all of these subdivisions. South, north, east, north, I'm sorry, that I'm so easily distracted by things. Okay. Northeast, southwest, southeast. Okay, so this is going to work. So each one of these, I'm making a new quad tree for each one of these subsections. But they need to, when you make a quad tree, you need to give it a boundary. So what I need to do is say, I'm going to say let northwest equal a new rectangle. That is, so northwest is up here, x plus width divided by 2, y minus height divided by 2, and then width divided by 2, height divided by 2. So I'm going to make a new rectangle that's at this dot x plus this dot w divided by 2, comma this dot y minus this dot h divided by 2, and then this dot w divided by 2, this dot h divided by 2. So that is the boundary for the northwest quadrant. And then I'm going to pass that in here. And then I'm going to do the same thing for northeast, for southwest, and southeast. So, oh, shoot. My mic is still working. Okay. Okay. Southwest and southeast. So now though, northeast would be x minus, and then southwest and southeast are plus, southwest is x plus, and southeast is x minus. So does this make sense, right? Plus, minus, and then minus, minus, plus, plus. So I think I've gotten all the quadrants here. So I've made rectangles out of all the quadrants and put them into variables. Now here's the thing. I don't always want to subdivide, right? I only want to subdivide if I haven't already subdivided this quadrant, this quad tree. So I could check, I think what I'm going to do is I'm going to make a variable called divided, which is false. And then I'm going to say if not this dot divided, this dot subdivide, and then this dot divided equals true. Now what I need to do is, if I'm at capacity, remember I'm inserting a point. The whole thing that I'm doing here is inserting a point. All right, hold on, time out. Hold on a second. The chat is telling me I have some east-west confusion. west, east, west, east. North, north, south, south. Oh. I've made a pretty big error here. I've gone off the deep end writing way too much code before testing it. There is no, this refers to this particular quad tree. There's no this.x. What there is this.boundary.x. Boy, this is going to make this super long-winded. Let's do this. I kind of feel silly doing this, but I think this is going to make our life much easier, just in terms of being able to read the code. So I'm going to make, this is totally unnecessary, but just to make the code more readable, let's make some local variables to this function that are kind of like aliases to this longer way. And then I'm going to start over again, and I'm going to say x plus w divided by 2, y minus w divided by 2, w divided by 2, h divided by 2, and this should be h. And now I'm going to put these all back here. North, east, south, west, south, east. And this is x plus, x minus, x plus, x minus, y minus, y minus, y plus, y plus. Am I right, finally? West and east are swapped. No. Oh, no. Oh, God. Also, west and east are swapped. Oy. Northeast, I'm going to do it this way. Northeast, northwest, yeah, southeast, southwest, right? Because east, west. If this is the center, right? East to the west, north to the south. Okay, everybody, I think I've got it now. Oh boy. So now I need to pass in those boundaries. Northeast, northeast, northwest, southeast, southwest. I have a really bad feeling that about 15 minutes of this video is me just trying to figure out north, south, east, west. The good thing is that part's done. I think we're good now. I'm going to just pause for a second to just check this code one more time. No, okay, so in the chat, the suggestion is being made, top left, top right. The suggestion is saying, shouldn't it be w divided by 4? And that's actually not the case, because I am thinking of w and h as not being the full width, but actually being the half width already. It just makes life easier to sort of sort all this out. So I'm actually just moving over half of w. Okay. Yeah, rec mode center, but I'm not drawing anything yet, so I'll need rec mode center if I start to draw some stuff. Okay. Okay, so I'm feeling pretty good about this code. There still could be an error there, but I'll find it later if there is. So remember where we were. We were checking if it hasn't been divided, subdivide it, and now what's the whole point? Remember, the whole point of what I'm doing, I was just saying this before I found all those errors, or the chat found all those errors, that I'm trying to insert a point. So if I'm at capacity, now I just need to insert the point in my subsections. So I can actually say, remember, these subsections are all quad trees. So I can recursively call the insert function on those. So I can say this dot northeast dot insert that point. So let me do it to each one of these. Northwest, southeast, southwest. So think about this. I'm going to get rid of some of this extra white space. The idea here is that, okay, if I have room, I'm going to take the point and I'm done. If I don't have room, then I need to check, do I have some children quad trees? If not, if I don't, I'll make them. And then I'll just say, I'll just sort of say, hey, pass the buck here. You take that point, all 4 of you. And all 4 of those will say, do I have room? But here's the thing. I'm missing something kind of important here. Should I really be taking that point? Now, it kind of made sense at the beginning that I just said, well, do I have room? Take the point. But really, I should be checking, is this point something that's within my boundary? That's the whole point of this. Because now that I'm going to say, hey, all 4 of you, only one of those should really actually take the point, right? So what I really need to do before I even insert the point at all is I need to say something like, if this dot boundary contains the point, and better yet, something like, if this dot boundary does not contain the point, then just get out of here. Like, I don't want to do anything if I don't contain the point, stop, don't go any forward, I'm the wrong path, I'm the wrong section, some other section is going to take care of it. This dot boundary dot contains, well, that means in my rectangle function, I need a contains function that returns true or false based on some point. So what I can say is I can say, hey, or I can actually just return point.x, and this is going to be really long, point.x if it has to be within all of the bounds. So it's got to be greater than this dot x minus this dot w. And I can put these, I think, on different lines just to point.x is less than this dot x plus this dot w. And point.y is greater than this dot y plus, boy, this is a really exciting thing I'm programming. And point.y is less than this dot y plus this dot h. Okay. Oh my goodness. Minus and plus, right? Remember, contains. This is a function that checks if this particular point is within the boundary. So is a particular point within the center minus the width and the center plus the width, the center minus the height and the center plus the height. And I'm going to stare at this code for a second to see if it's right. Nobody's written anything that it's wrong. This is all going to get edited out, so I've frozen myself at this position. Okay, I feel like that's pretty good. So why not? Let's keep going here. So if it's not in here, go away. Otherwise, if I'm not at capacity, add the point. If I'm not divided, subdivide, and then just try to insert to all these children points. Now, I feel like I need insert to kind of like return true or false, but I guess because at some point it's going to be done. But I think this is actually pretty good. Looking at the chat, contains is a reserved word. No, it's perhaps missing the point equals boundary stuff. Break up the existing points. I shouldn't be reading the chat so much because it's distracting me from my flow. I should just keep going and make all my mistakes. I'll come back to them later. As someone earlier mentioned, subdivide needs to handle existing points, and it can set subdivided itself. Oh yeah, that's a good point. Yeah, it could handle the points, but I'm gonna keep it the way I'm doing it. But that's a good point. Okay, I had a nice suggestion from the chat, which that maybe it makes sense to in the subdivide function actually set this dot divided equal to true. Okay, so let's think about this. How am I doing here? What is this going to do? Let's actually try running the code. All right. So I have a boundary. Its capacity is 4. It has a points array, and it got a point. That's good. That's great. Let's add 4 points. All right, look at this. I've got a boundary, I've got a capacity, divided is false, and I've got 4 points. Great. So now if I add 5 points, it's definitely going to have to subdivide. Let's see how that works. Let's add 5 points now. I could have changed the capacity to smaller. Oh, we've got a problem. So look at this. When I set in the constructor this property n as the capacity, but when I make these new Quadtrees, I'm not passing that in. So I could do something like this, but I think I made this a little extra complicated, but let's pass in also the capacity. So that capacity needs to continue to be there. Now let's try with 5 points. All right, look at this. It's got 4 points. Where's that 5th point? Where's that 5th point? It's not in the northwest, east. It's not in the northwest. It's not in the southeast. It's in the southwest. Because, does this seem right? The point is 104, 354. That sounds like southwest. Yes, southwest. West is this way, south is this way. So I think this is working. I think we're kind of getting it subdivided correctly. Let's try 50 points. No errors. I've got a Quadtree with a capacity of 4. It's got 4 points. Northeast has a capacity of 4. It's divided. It's got 4 points. It's got a bunch of subsections, which have, this one just has 1 point, but maybe this one has no points. So I think this is working, but here's the thing. Is this working? Looking in the console is only going to get me so far. I think what would help me now to see if this is working really is to visualize it. So I'm going to break with what I said at the beginning, which is trying to purely have this. I think what I want to do, I kind of want the Quadtree thing to be independent of P5, but I'm going to give that up just for a second because I want to write a function called Quadtree show. And what I'm going to do here is I am going to add a function called show. And what is this going to do? I'm going to say stroke 255, or let's say stroke 255, no fill, and I'm going to draw a rectangle at this dot boundary dot x, and this dot boundary dot y, and this dot w times 2. I need to say times 2 because P5 expects the full width. This dot h times 2. So I'm drawing the rectangle for the boundary. And then, sorry, I'm thinking about this for a second. And then, then I want to recursively draw any of its children boundaries. So if this is divided, then I can say this dot northwest dot show. So I want to recursively northeast, southeast, southwest. Doesn't really matter what order, but just to be consistent. Northeast, northwest, southeast, southwest. Let's take a look. Oh, rectangle is not defined. Quadtree.js, rect in P5. W is not defined, line 73. This should be 2. And then let's see here. Background 0. All right, what happened here? Oh, I'm running out of battery. Timeout. Where is the power? That's one power. Here's another power. Don't worry. All right, what mistake have I made? Thankfully, the chat is here to tell me that this is this dot boundary right? I'm always confusing and forgetting that the x, y with height properties are in the boundary object, not part of the Quadtree object itself. So we can say this dot boundary dot h. So let's see what happens now. There we go. Ooh, everything looks like it's right but off kilter. And this is an easy one. I forgot to say rect mode center because I want to draw the rectangle space on the center. There we go. This looks good. Now let's actually draw the points. Point, let's say for let P of points, this dot points. And let's just say point, point P dot X, P dot Y. So this isn't very many points, and it's very hard to see those. So let's say stroke weight 4 and stroke weight 1 up here. Stroke weight 1. And let's go to sketch.js and let's make 500 points. And there we go. This kind of makes sense, right? You can see for whatever reason, there are not as many points here, so it didn't need to subdivide, but it did subdivide here. We never got anywhere to subdivide beyond just this size, right? Is there any? So what's kind of unfortunate about this is because I'm calling things randomly, because I'm setting the points randomly, the subdivisions are just like perfect. It's so evenly distributed that the subdivisions aren't that interesting. Let's change this. I have an idea. Let's actually add, let's get rid of this. Whoops. Let's say, let's add the draw function. And I'm going to say if, I could use mouse drag, but I'm going to say if mouse is pressed. And I'm going to say, because I have an idea here, well, first I want to always draw it. And then I want to make a new point where the mouse is. And I want to insert that point. And I need this to be a global variable now, the quad tree itself. And I'm just going to call it tree, because I don't like Qt is sort of I think it'll make it a little bit more, I could say call it Q tree, kind of like that. Q. Okay, so bear with me for a second. What I'm doing here is I want to insert points where I'm clicking the mouse. So with this show of undefined, oh, whoops, I do not want to redeclare QTree with let. So we can see as I draw, it has to subdivide more where I am. That's kind of cool. Why does the frame rate seem so slow? Sorry, hold on. Interesting questions in the chat. Yeah. There's so many good questions in the chat here that I want to address. But I got to come back to that. I got to try to remember. People are asking about the edge cases, if something's equal, and people are asking about shouldn't I move the points into the subsections, but for a second here, this is all edited out here, Mattia. It feels like it's running really slow. Whoops. 30 frames per second. No, it's just that I'm not using mouse dragged. So that. Oh yeah, I need to do greater than or equals on a couple of the edges. Okay. I'm just trying to think of what else I want to do here. Because what I was going to do is insert a bunch of random points. So let me actually insert, what I wanted to do was just insert a bunch of points. I think this will make it more interesting to look at. Like if I actually insert 5 random points whenever I'm clicking the mouse, and we can just set these like a little bit randomly around one area. And let me run this again. Yeah, so you can see I'm just getting these like subdivisions. And so now we can sort of see that what I'm doing here, and is I'm getting a nice, it's subdividing more where it needs more subdivisions, if that makes sense. Now, I'm being asked a couple different questions from the chat. Number one is edge cases. And what do I mean by edge cases? What if the point is exactly on the edge of one of those sections? I didn't account for that. The truth of the matter is with these random numbers and floating points, but this could really happen. So what I think that I need to do here is in the insert function, in the contains function, what I need to do probably is just consider whether it's less than or equal to. And I could do that on just 2 edges so that it would kind of, but what if it's on the edge of the very edge? I don't know. What I could do is just kind of be inclusive. How do you write these? Like this? And this should take care of that, because I'm gonna just say, if you're on my edge, I'm gonna take you. Don't worry. And I probably could get not, but I'm not concerned too much about the accuracy of this. And you can see, so same thing. And interesting, it's really subdividing a lot in these areas. So here we go. So this is kind of an interesting visual result. Like I almost want to go back to not drawing the points now. Like let me take out the points, because now I'm able to draw. I'm kind of like with my mouse, I'm drawing this kind of interesting recursive tree pattern. Doesn't seem like a tree, but it's all, if I were to unpack the way it's stored, it's all this nested tree of rectangle objects. Okay, so what have I really done here? I have made the quad tree, but I'm missing kind of a really important point. Because what I want to use the quad tree for is to query it. I want to say, hey, this area, could you please give me all the particles back that are in that area? And I think what I'm going to do is make that part 2 of this coding challenge, because this first part of the coding challenge is finished. I've made the quad tree data structure and I'm storing the points in it. I do want to address one question. This will add, yes, okay. So hold on, I realized that. So the thing is, it is going to add it to more than one of these, which is a problem. Hold on, just time out for a second. I forgot, I do have to only do 2 edges. The thing is, I kind of want, if it's added it to northeast, I want to just jump out of this. So, I want to say, I think what would be nice is for this to do something like return false, return true, so that if I don't have to check the other ones, I think that's going to be, I'd almost rather do it that way, and I'll just take the first one. Simon says you can have the points be a different color. That's an interesting suggestion. Oh, like just make them random colors? Oh, a different color than the boundaries. Yes, that would be good. Yes, okay. Okay. Boy, I'm really making this an editing nightmare, but all right. So before I leave, it was rightfully pointed out to me that the way I just did that with the equals is that it would actually go into, if it was exactly on the edge between like east and west, it would end up in both of these quad trees, which is a bit of a problem. So there's a couple ways I could address that. Again, though, what I want to do here is I want this function, the insert function, to return true or false whether it succeeded in inserting the point. So it should return false if it's not contained, and it should return true. It should return true if it is actually inserted into the points array, and then I can just say, if I can wrap each one of these, I can actually just return the result of each one of these, right? So that way, oh, no, 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 I can't do this. Because I don't want, I really have to say, if it only if it's true, return true. This is a little awkward, but this is fine. Well, you know me, I like to refactor later. So what this is going to do is it's just going, I could use an else at least, I guess. Right, because so what I want to do is I want to find, it's going to, I want to find where it's been, where it's got inserted, and then I want to return true. Okay, so all this extra stuff I'm adding here, maybe this is silly and I should have just thought of the boundaries more carefully, but this is going to guarantee that it's only ever inserted into one. And it is giving slight preferential treatment to northeast, because if it's on the boundary, it's always going to go into northeast, as opposed to it'll never get to northwest, but that's okay, I think. So let's just see if this is still working. It is. Somehow I like imagining it's working faster, but I don't think it actually is. Wonderful. Okay, am I really at the end now? There's a nice little, people are giving me all sorts of suggestions about how to improve this code. I could use like an or. And so I encourage you to make a much nicer version of this in your own code. I'm going to leave it like this because it's really explicit about the algorithm. I do want to write some comments in here. So I'm going to finish with this first part 1 of Quadtree. I've made a Quadtree in like only 4.5 hours it took me. And I'm going to do a part 2. And in part 2, what I'm going to do is ask for a selection of points within a certain boundary. And then I can apply that to a collision detection problem and make that collision detection problem much, much faster. Okay? So thanks for watching this part 1, and watch part 2 if you like. It'll be next, and you can find a link to it in this video's description. Or in contains is much faster. Oh, you mean just check if it's outside? Yeah, that's a really good suggestion. So actually, this is a good point. Someone in the chat, now it's scrolled past. Public MI. So I could do an or, right? Instead of saying if it's this and this and this and this, I could just check sort of the opposite. If it's not anywhere within these boundaries, it's not within the boundaries. So let somebody else up. I think I want to make this like, even though this will go as a coding challenge into my GitHub coding challenges repo, I think I'm going to make a standalone Quadtree repo that'll make this into a little library. Okay. Simon, the colors are things I encourage the viewers to add and make better. Simon, I would like to know, had you ever heard of a code tree before? Quadtree? A code tree. My brain is like, it's barely alive. It's 5:20. I can do the second part. All right, so how do I do this second part? Let me think about this for a second. Let me look at the Wikipedia page. The Wikipedia page algorithm is insertion query range. Oh, right. I just check if it's intersecting, and then I give it those points. No, points in range. Wait. Oh, emptiness. Right. If it's not, no, I say if it's not intersecting, then give it an empty array. Otherwise, give it the array that it contains. If it's not subdivided, you're done. And otherwise append the result. Oh, yeah. Okay, sorry, I just looked up this pseudocode algorithm. That was very helpful, so I don't have to, just needed a little help there. Okay. This is like totally, what I'm going to do is just change this to, because it is just I really should have the whole time been doing this with mouse dragged, because I don't need to recalculate it. It's just like eating. My fan is spinning. So let me just, this is a bit better. Yeah, I don't know why I didn't do this in the first place. Okay. All right. Okay. Right. That's a very good point. So when I do this now to determine if I've done it correctly, I do need to have the points be different colors so I can see if it really works. Okay. So let me put the points back in. Put the points back in. I'm like picking my nose live on air. Thanks, everybody. Let's make a color here. Okay. And let's set the background here. All right. Okay. Mic is still working. Okay, here we go. Okay. Welcome to I'm taking this very seriously. Welcome to Quadtree Coding Challenge Part 2. I am going to, in Part 1, I implemented a quad tree, meaning I made a data structure that tracks every point. Why is it so slow? I'm not going to worry about that right now. Is it the drawing that's slow? I think it's the drawing. I got to come back and start this over. But there is no frame rate now because I'm doing this in, the frame rate idea is meaningless. Look how slow it became. Is this just JavaScript? Oh, different color per cell. That's a great idea. Hold on, maybe that's just that I'm adding so many points. I think something is going wrong here. Hold on, I'm not doing Part 2 right now. I want to just, I like this idea of a new color. So let's just add this in for a second. And I'll just make it a random one. Let's make it 2. I guess let's put that back to 4 because, yeah, it is working as far as I can tell. So why is this one green? Well, the reason why this one is green is it was actually probably in the full one first. Then as more got added, it had to subdivide. So these blue you can see, but these are within this. So it's a little, yeah. But I'm pretty sure this is working right. I just feel like it's weird that it's running so slow. Maybe it's not. Yeah, I mean, I guess JavaScript is slow. And this computer is probably like, Oh, wait a second. No. Oh, set the color on this. That's a good point. So another thing I can do is I can say, that's a good idea. Fill this dot color. I need to give it some alpha though. This is silly. This is so silly what I'm doing. Ooh, fun. Pretty colors. Pretty, pretty, pretty colors. Yeah, you know. The other thing I could do, actually, by the way, is that it's not so insane to make the capacity just 1. But it's sort of hard to figure out what's going on because it was mentioned in the chat before. What if you subdivide, you should add the parent's point to the right subdivision. So I'm not actually doing that because the problem, then I've got a capacity. I guess you could make the argument that you should do that, but I think the typical Quadtree implementation doesn't do that because you can do that, but it doesn't add any efficiency necessarily. It's fine for you to just check those first 4 points always in the higher level, and you're just getting more and more detailed as more and more points are added there. Set the color on the cell and draw the point. Draw the point with the cell color to make sure each point in the right cell. I'm feeling somewhat confident that it's actually working because each one of these only has 1 point. That has none. So right, 1 point here. I don't see what making the background white would do, but I do like the fact that it's colorful. All right, I think JavaScript is just slow. And it's actually not the Quadtree that's slow, it's the drawing. Like, watch this. So let's do something here. Let me add 10 points. And let me console log, watch this, frame rate. I think it's just the drawing that's slow. Whoops. So you can see, look at this. Now it's going at like 4 frames per second. However, let me comment out the show function. So I'm doing everything but drawing. I'm inserting all the points into the Quadtree so many times over and over again. It's just not really, it got a little bit slower than 30 frames per second, but at this point, there's a lot of points because I've added so many points. So now I feel okay about it. It's not the algorithm that's slow. Only draw the rectangle if it has no children. That would make sense. So that's a good idea. That's interesting. Let's look at that though, because that'll be nice to see. And then in show, if not this dot divided, draw the rectangle, and the points, else if this dot divided, whoops, what did I do here? Oh, if it's not divided, else, oh no, whoops. I think this is right. And I made it, let's make the capacity 4. Yeah, by the way, It's funny, right, it's hard to sort of see if it matches, right? Because I put some alpha there. That's why you're saying make the background white. Yeah, you can see that it's right. This is cool. So you can see that there are, right? But interestingly, why? Oh, yeah. Right? Yeah, this is cool. Watch. So if I just kind of click, it does a few points. It's not subdivided yet. Now it's subdivided. I don't see those other points anymore, but I see those 4 here. Subdivided. Now there's only one new point in the new section. Yeah. So I'm pretty happy with how this is working. And in fact, it's just the rendering that's quite slow. P5 disable friendly errors equal true at the top. Yeah. That's actually, let me try that just out of curiosity to see. I forgot about this. This is a little tip. P5 dot, oh. What is it? P5 disable friendly errors. Disable friendly errors equals true. I think also if I use the minified version, it kind of does this automatically. Oh yeah. This seems to be running faster. This is so lovely. I'm kind of addicted to this pattern, actually. Okay, so I'm feeling pretty confident that the algorithm is working correctly. And so what I want to do is, unfortunately, I've done all sorts of craziness to this. I'm going to take out the color stuff. And I'm going to put this back. I just want to put it back to what it was. Show if this is divided. Yep. Stroke weight 1. Whoops, and let's get rid of, by the way, this is like a terrible thing to do. That's really going to slow it down also. Let me put background to 0. Okay, so I'm back to what I was before. And, okay. Okay. All right, so let me get to this part 2 now. I'm actually pretty confident this is working. And so what I need to do now, I mean, ultimately I'm going to want to use this with like the flocking simulation. Or just even like a collision detection example. That's going to be part 3. But what I want to do now is just arbitrarily check to see, retrieve a certain number of points within a certain area. Okay. So what I'm actually going to do is I'm going to comment this out. Put this back and add okay. And one thing that I could do, one thing that I could also do is just make the canvas smaller. You know, blow it. This is actually going to just have it run faster. Now I have an idea. God, it's so evenly distributed. I have an idea, which is that, is there a random, I think it's the mean and a standard deviation. So I'm just going to use this random Gaussian for a second to have the points cluster around the center. Yeah, there we go. I'll explain what I'm doing in a second. Yeah, this is better. Let's put it back to this. Okay, yeah, this is good because it's showing me, and let's make these stroke weight 2. There we go. Okay. Okay, all right. So Simon asks, why is this collision detection? So I'm going to have to get to that in part 3, which I don't know if I have time for today. But let me at least do part 2. I have to just check a message here. All right, wow, there's 800 people watching. That's nuts. All right, here we go. Okay, this is part 2 of my Quadtree coding challenge. And so I made a few adjustments. I used something called a Gaussian distribution of random numbers to pick a whole bunch of random points that cluster towards the center. So at least we can sort of see the Quadtree is subsectioning the canvas area in a way that's not sort of uniformly distributed. So it allows us to sort of like check and see if this is working. So what I want to do right now is I want to basically like pick an arbitrary section. Like I want to just say like, you know, some rectangle like down here. Like for example, let me make a boundary. So let me make, down here, let me say, let the query be a new rectangle, and I'm going to make something totally arbitrary like 200, 200, 100, well, hold on. Let me think about this for a second. 350, let's start this video over. Can I hide this somewhere? If I put this like, I don't want anyone to see that. What if I put this here? Will this actually work? Right, because I'm not going to go look at this HTML file. Don't need this draw function. Hold on, I'm starting over. Starting over! If I look to the right and yell, does it not blow up in your ear? Okay. We're good. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. Okay. Hello, welcome to part 2 of my coding challenge, Quadtrees. So what I want to do in this part is I want to look at how I can retrieve a list of points from a given area without having, and this is going to, I don't have to, like I could say like this boundary over here, give me all the points in that area. Well, I can just look through every point and see if they're contained within that boundary. But the Quadtree is going to allow me to do that more efficiently by kind of looking at the sections that are near this particular range that I'm going to create. Oh, boy, am I not explaining this well. Let me explain this visually. So what I'm going to do, let me just draw a rectangle. Let me say something like stroke 0, 255, 0. Let me draw a rectangle, and I think because I'm going to say rect mode center, and I'm going to draw a rectangle that's, how big is the canvas? 400, 400. So I'm going to go over to like 300, down to like 300, and I'm going to say 100, comma 50. So, and this is way too exact. Like, so let's say 107 and like 92. Okay. So, and I don't know why it's really bothering me that, there, okay. So basically what I want is I just want the points, and there's not a lot of points there, so let me move this over. I'm really wasting so much time on this. Perfect, this is what I want. What I want now is to say like, just give me all the points that are in this area. but I want to ask the QuadTree for it because the QuadTree is going to have a capability of giving me those points more efficiently. It's not going to have to check every single point. So let's see if I can do that. So in order to do this, what I need is in the QuadTree, I need a new function. And I'm going to call it query. And let me put it above show. Show is just sort of a drawing stuff, which is really just for debugging at this point. I'm going to write a function called query, and it's going to take as an argument a range. And what that range is, it's essentially a boundary. I don't want to use the word boundary because it's going to get confusing, because the QuadTree object itself has a this.boundary. Whoa. Whoa, did you guys hear that? Okay. No. Nobody heard that. There was like a really weird sound. I'm like frozen in. Oh, you did, yes. Ooh, what was that? That was weird. All right, let's keep going. Simon's saying make it random. I'll make it random, but later. First, I want to just use that fixed area. Okay, so query the range. So the first thing I need to do is I need to say, does this range and this QuadTree, do they overlap? If they do, then there might be some points that I want to give you. If not, it can be ignored. And if it can be ignored, that means I don't have to check any of the points that are in it or any of its nested subsections. So that's the first thing I need to say is say if this dot boundary dot intersects range. If it does not intersect the range, let's just get out of here. I'm done. I don't need to look. I don't need to look away. I don't need to look any further. I'm done. I'm going to have to change this in a little bit, but this should work. Now, here's the thing. If I'm saying if this dot boundary intersects, well, I've kind of got a bit of a problem here, which is that the boundary is a rectangle object, and I don't see an intersects function. But guess what? I can write one. So, oops, idea. I'm going to write an intersects function. Intersects another, I'm going to say range. Why not range? So, oops. So there was another coding challenge where I had to do this. I can't remember what it was. It was one of my early coding challenges where I had to test, do two rectangles overlap or do they not overlap? And I think there's a nice way of doing this with an or, basically saying, hey, if any of these conditions are true, they can't possibly be overlapping. For example, if the x of this one is greater than, well, if this edge is greater than that edge, or if this edge is less than that edge, or if this edge is greater than that edge, or if this edge is less than that edge, if this is anywhere outside, then they are not intersecting. This is going to be so painful to write. There's got to be a really easy way to write this. Okay, so let's think about this. If range.x minus range.w is greater than, right? So if this is the rectangle range and this is its left edge is greater than this right edge. Actually, this isn't going to be so bad. Is greater than this dot x plus this dot w, or right, range dot x plus this dot w is less than this dot x minus this dot w, or I think I can do this now with the y's. Range dot y, h, y, h, h, y, h. This is really, you're watching a person here type this stuff. H. All right. So, and I want to return this, not if. I want to return. So if they intersect, if this is true, they don't intersect. So I want to return not this whole expression. Yeah, I think I did it. I'm going to stare at that code again for a little bit. I'm waiting to see a lot of people in the chat say, it's right, you can move on. Mathieu, maybe this is one of these moments where we can do the speed up thing. I think it's without the negative width if the position is in the corner. Frogger is the challenge. All right, I gotta look at this myself. Oh. Oh, that's an interesting way of doing it. All right, nobody can seem to tell me that I'm wrong. I stared at it enough time. I'm going to move on. Also, it was pointed out, it was the Frogger coding challenge where I struggled through this for a very, very long time. So I could go back and check my Frogger code, and I probably could also use somebody else's library that has like geometry math in it, but let's move on. Okay, so now, if this should work. Now, what if they do intersect? If they do intersect, here's what I need to do actually. So I need to recursively go through everything. And I'm gonna say, I want to have I'm gonna create a variable called found. So I want to find all of the points. So if they don't intersect, return found, it'll be an empty array. So this will be an empty array. Otherwise, now, if they do intersect, let me look through all the points that are part of this quad tree. All the points that are part of this quad tree, and say if range.contains p found.push p. So now I know that the boundary and the range, that this quad tree intersects that range. So let me check all its points and see if they're within the range, then I can add them. Perfect, I've added them. And now what I need to do though is say if this dot divided, then, okay, well, basically what I want to do is I'm going to return, so then I should return those points, right? But before I return those points, what do I need to do? Well, if it has some children, Quadtrees, then I need to check if any of those points are in there. So what I need to do is say if it's divided. So if it's not divided, I can ignore this. I can say return this dot northwest query range. But I don't want to return. I need to pause for a second here. I need to think about this. What I'm going to do is, no, I'm going to I think I could just concatenate. Yes. All right, I've got an idea. Okay, I know it's going to be easier here, right? I could pass the array and keep adding to that array reference, which is I think what you would normally do with recursion. But for some reason, the way that I'm thinking about this right now is I can say found.concat this.northwest query range. And then I can say northeast, southwest, southeast. What this is going to do, and then I can return found here. So what I can do is, right, I'm going to start with an empty array. If it doesn't intersect, just return an empty array, and all this concat stuff is going to concatenate. Concatenate should just join two arrays together. So what I need to do is, if there's nothing here, move along, return nothing. Otherwise, if there is something here, check my points to see which ones I should add. Then if I've divided, I should also add any of the points that are from my children. And then when I'm all done finally, I'm going to return that array. I think this is good. I'm sure something's wrong here. I'm going to get rid of all these extra line breaks that I don't need anymore. And now, here I should have, okay, so I have this rectangle, but this is actually, I need to say a range is, and I really should make this, let range be a new rectangle that is 250, 250, 107, 75. And I'm going to divide those by whatever, that's fine. I'll make it bigger. And then I'm going to draw the rectangle at range.x, range.y, range.w times 2, range.h times 2. So let me just take a look at this. W is not defined. Whoops, times 2. All right, so I just made it a little bit bigger. So now what I want to do is I want to say, oh boy, let points equal QuadTree.query range. And just to see, let me console.log that array. Without even trying to draw stuff, let me just see if this function even returns anything. It gave me 3 points. Okay, so this can't possibly be right. I've done something wrong, which is that I only got 3 points. So a bunch of people in the chat, I can't credit everybody telling me the concat method is used to merge 2 or more arrays. The method does not change the existing array, but instead returns a new array. This is from Pierre in the chat. So what the issue there is, and maybe now I'm kind of don't want to use this concat, because I have to write this, right? I have to say, I think passing the array is going to be better. So apologies. I'm going to say return. I kind of like passing the array better. So query range array. If no array, then I'll call this found. Then found is a blank array. So I create the array if it doesn't exist. Then I can just return the empty array. Then I can push the stuff here. And then now I can get rid of this crazy. This concatenating idea was very silly. I don't know who thought of this. And whoa, I've got extra parentheses like mad here. Now I can say with the array, and I can just pass the array. So I'm just going to pass the array around, and I actually don't even need to, I do want to return found when I get, you know what? Yeah, let's do this where I, because now I want to return it, but I only want to return it at the end of the very first. So I think, let me do it this way. There's got to be a better way for this, but let me just, to get this work, let me pass in an array. I'm going to think about how to return it better in a second, but let me create an empty array and then pass it in, and then we'll look at that array. So, okay. This just gets me out of here, et cetera, et cetera, et cetera. Okay, okay. Here we go. All right, 160. That makes a little bit more sense. There could be 160 points in there. So let me now, in the sketch, let me say for let P of points, and then stroke 0, 255, 0. I guess I already have that. Let me draw the points. And let me say point P.x, P.y. So let's look and see if that worked. Hey, this is looking pretty good. Pretty good. All right, let's make this rectangular range random. So let's pick a random point, a random height, and let's give it some random width within 100. Actually, let's just always make it 100, 100. And let's see what happens. All right. So wherever, oh, wait. Why are there some points here not showing up? Something is wrong. All right. Yeah, not all the points are selected. We're going to have to look into this. Could be my intersects function. This could be wrong. Contains function, I'm pretty sure, is right. Oh no, that's right. Found push. Oh. We've told you a million times you've mixed range.w with this.w and range.h with this.h. In the intersects function, intersects was wrong. Guess what? Remember this function that I spent like an hour staring at? Apparently, I was looking at the chat the whole time. There's a significant error in here that I have mixed up. Oh yeah, look at that. Range.x plus this.w. Ooh. Range.w. Range.h. Range. This. I got to stare at that for a little more time. So it's also being pointed out in the chat that you use the width as the full width instead of the half width. And that, I don't think that's true. I think I'm being consistent about, it's confusing because the only time I ever need to not think about the width as half width is when I'm drawing it. So, all right. All right, so I think that's corrected it. We'll find out. I can't find any points. Oh, look at that. Look at that beautiful. I found all the points within that region. Now, just out of curiosity, right, if I had to check every single point, I'm just sort of curious here. If I had to check every single point, right, this is where in the query, this is where I'm looking through all the points. If I had to check every single point and I had like a global variable, oh, sorry everybody, pause. If I had to check every single, oh, I should make the query rectangle move with the mouse. That's such a great idea. Hold on. If I had to, I just want to check something for myself. If there are 300 points, so if I create I'm just going to create a global variable called count, right? And if I were to check every single point, I would if I would look through every single point to see if it's within that range, count plus plus, count would equal 300. But I am going to here, just as a little sort of like hack check, is I am going to increase the count here. And I shouldn't have to look at all 300 points. I should be looking at a subset of points. So let me console log that count. 31, 27, 48, 219. Now, of course, I've got to look at a lot with this big range because I kind of got picked randomly through the center. But I never have to look through all the points. And so this algorithm, if I make the range the whole canvas, well, then I have to look through all the points. The point is, if my range is something much smaller, like even if it's like 25 by 25, right? I only have to do very, very few checks, even if it's randomly in the center. And let's get rid of this count idea, because I don't need that count idea anymore. Let's go, this is going to be fun. Oh, so much fun. Let's go put this in draw. And let's make the rectangle mouse X, mouse Y. Count is not defined where at draw sketch.js line 26. Oh, Quadtree line 87, sorry. Quadtree line 87, save. So now you can see, as I move the rectangle, it is highlighting only the points that it finds. I kind of want the count back. Because I kind of want to know how many checks, but this is great. All right, woohoo! I think I've successfully now implemented the full Quadtree because I have both an insert function and a query function. Let's quickly go to that Wikipedia page. And if we look at the pseudocode, right, we can sort of match this up with what we did. There's this idea of a point, an XY, an AABB, which is my rectangle, an axis-aligned boundary box. There's the Quadtree class. It has a capacity, it has a boundary, northwest, north, all of those things. We have an insert, subdivide, and query range, right? Query, insert. Yeah. So I think that I have basically done everything. And probably, I did read this Wikipedia page the other day, and that's why I think I started using concat, because it's using append. So, but I think I like my, so here's the thing. I really should this video should be over because it's taking way too long. But I do kind of I really sort of want this. Oh, I know what I can do. I want to return the points array. Let me fix it so it returns the points array. Let points equals query that range. So I really just want to get an array back. So now if I go in here, so if found does not exist, found should equal an empty array. And then can I just say return found down here? Is that going to work? That works. I don't know why I thought it was so complicated. The reason why I kind of was afraid to do that is that these are also returning the reference to the array, but it doesn't matter because I'm not doing anything with it. So that's fine. So the only return that really counts is the very, very, very last one, which is the original call to the query function. So now, okay, that was much easier than I thought. So now at least I have the function return that array. Okay, I'm going to be done. There's one more video I need to make. And I think, though, there's many more videos I need to make. But part 3, it's going to come later. Hopefully by the time you watch this, it might actually be linked to. But what that video is going to do is I want to apply the Quadtree algorithm to a collision detection problem. And in particular, a really good one for me to apply it to, it's not really collision detection, is my flocking simulation. I also would like to port this to processing and make a Java version of this. So those are all the things that I want to do. But if you're watching this video right now and the next one isn't available, as a challenge to yourself, see if you can take this and apply it to a collision detection problem. And then I'll be back and doing that myself someday. And that's what's going to happen. Okay? Thank you, everybody. Okay. I unfortunately have to leave. It's after 6. So this is going to have to be very much of a to be continued. Anything that I have really, please show the counter and target a single point. Pretty sure some points are counted twice or more. That's possible. Something else asks, would this be hard to expand to 3D? It's called an octree. So in 3D, you would use an octree because you'd have 8 subsections. Right? If you think about a cube that you would divide into subsections, wouldn't it be 9? Oh no, 8. I don't know. Whatever. Read the Wikipedia page for octree. My brain is dead. Right? If I go down here to octree, you can see, you're right. Octree. Yeah, of course it's 8. You can see this subsection recursive subdividing. Yeah, the daylight savings hours are different, I think, between the US. Kay Weekman asked about daylight savings time, which is something that I'm absolutely equipped to discuss. I believe daylight savings, it's now Eastern Daylight Time. That was like a week ago. So we're now at a 5-hour difference. And then Europe, maybe you do it this weekend, we'll be back to 6 hours again. I think that's right. It is time in Zurich. It is 11:09 p.m. That is the time that it is for me right now, at least mentally. But however, in Reykjavik, it's only 10:09, but that's because there's an hour difference between those two places, just in case you're wondering. QuadTree is better. Yeah, I should look into that. Yeah, we don't change until next weekend, right? UK changes on Sunday night. Oh, it's 10:09 in the UK? Oh my God. Really? Oh, it's only 10:09. Oh, so like Zurich already changed? I'm so confused. Or Zurich is just an hour difference? GMT plus 1. Well, London is obviously GMT. All right, so this is like way more fun than I ever expected. I think you could probably make some colorful visualizations out of this. So I look forward to seeing what comes of that. Let me try to answer a few questions in 2.5 minutes. So I'm now going to take 2.5 minutes of questions. Of course, you're about 30 seconds behind me. Justine writes, is this JS and P5 only? So, well, the algorithm Quadtree is a generic algorithm that can be used in any programming environment. This particular example that I have made is JavaScript. The language is JavaScript. I am using the P5 library for the drawing aspect. All of the Quadtree algorithm, none of that depends on P5, but the algorithm itself, the drawing of it, I'm using P5. Is this exponential or linear as far as memory requirements? So I think what you're asking for is it's neither. So we're talking about the order, the big O notation of the algorithm, and this is not it. If I was the way I want to apply this algorithm is log n, just for that one. If there's n elements, it takes approximately an average of log n of those elements to look at to find all those points within the square. However, what I talked about earlier in the video is what I want to do is I want to do this for each and every point, arrange around it. So that's going to be n log n. Whereas if I didn't have the Quadtree, it would be n squared. I would never implement a Quadtree if I only had like 100 things, because why bother? But as the space grows really, really big, it can be much more efficient. Where did you get the music and the sound effects? It's sort of like some random stuff that I've pieced together. I would love for somebody to just like build me a whole like sound effects music board extravaganza. But I haven't had time to do that myself. You could add a function for changing the green rectangle size with the mouse wheel. That's a great idea. So I encourage somebody to add that to the code. Important question. What's on page 99 of a book of random numbers? Thank you for reminding me. Oh, I forgot to have Kat read the random numbers also. Why can I never remember to have the guests read the random numbers? Boy, brain is fried. 11,339, 19,233, 50,911, 14,209, 39,594, 68,368, 97,000. I feel like I'm in a Black Mirror episode or something, but whatever. 97,742, 36,252, 27,671. That's one line. That's one line of it. Okay. So far, the only guest I remember to have read random numbers is blah 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 blah. That are random numbers is Golan Levin. All right, got a minute and a half left here. Would it be difficult to add different shapes? Not necessarily. I would need an intersect function. So if I wanted to look at all the points contained within a circle, I'd need to have an intersect function for the circle and the bounding box. But that's no big deal. Like I just need a different contains function, but that would definitely be possible. Read the book of pi. Yeah. What was I doing in Switzerland, and do you do a meetup? So I haven't really done any official Coding Train meetups. Would love to do something like that. I mean, I was in Switzerland for a meeting that was at the Google office there, and that was really interesting and fun to be there, and that just wasn't enough. I was really, well, actually I ended up being there longer because of the snowstorm, but I was only there for, less than, something like 36 hours. So I would love to do, especially because I know there's a lot of viewers, there's a lot of viewers all over the world, but in particular I do know that there are certainly a large number of viewers in Europe. So I would love to do a meetup somewhere, and remember my Coding Train World Tour, someday that'll happen. Okay, opinion on Java 9 modules. Simic asked, what kind of sounds would you like for your sound music board? Tweet me at Schiffman, and I can kind of discuss it. So tweet at Schiffman if you want to help put together like music and sound stuff that I can use. I would love to hear from you. All right, so this is the end of today. Last question. Rick asks, is Java more powerful than processing? Guess what? Processing Java, completely, 100%, identically the same thing. It's not really, but processing is just a library for Java. So Java itself isn't more powerful than processing. Processing itself isn't more powerful than Java. Processing is just giving you a set of functionality that you can call with a certain API in the Java programming language. And in that sense, it's not more powerful, but maybe it makes prototyping a bit quicker and easier, get you up and running a bit faster, and do drawing stuff with less code. Okay, the next stream will be next Friday. So unless I have some surprise extra live stream during the week. Thanks everybody. I will see you next Friday. I have a guest coming. That's I'm very excited about. So stay tuned for that. All right, there's a little teaser there. Oh boy, a YouTuber, one of my favorite YouTubers, is going to be here. I don't know when, sometime next week, definitely. All right, see you then. Goodbye everybody.